Okay, welcome to another Ginger Mathematician video. I've had a lot of suggestions for doing some work on the iGCSE 0580 Maths Paper 2, and now it is non-calculator. We're now in 2025 and it's going to be a non-calculator paper. And one of the ways to really help you revise those non-calculator skills is I've come up with this idea of the Maths Exam Sprint. So what is this? Well, it's a 25-minute mini paper, and we're really focusing on those fundamental non-calculator skills you need to know to make sure you do really well in that paper in 2025. So you can see one in front of you here. I'm going to do a walkthrough of this. So I'm going to go through each of the questions. Again, a link to this and the solutions is right down in the description if you want to access this and give this a go yourself. You see I've made up some rough grade boundaries for the 3 top grades. So if you're getting those amount of marks on the exam sprint, then you've got an idea of where you are in your revision. Right, let's get started. So we're going to do some fraction work to start with. Again, very, very typical. So we want to calculate these, leaving your answers as mixed numbers. We cannot rely on our calculator. So the first thing we need to do here is turn these into improper fractions. The way that we do this is we do 4 times 3, that's equal to 12. Then we add on the 2, that gives us then 14 over 3. So we want to convert both to improper fractions. Then we have this one here, 3 and a 6th. We convert that by doing 6 times 3, which is 18. Add the 1, that gives us 19 over 6, like so. Now, what we need to do in order to add fractions is we need a common denominator. Then we'd be a bit on the lazy side here because we can just change this fraction here by timesing top by 2 and bottom by 2. Remember, if you do the same thing top and bottom, it doesn't change what it is. So we get 14 times 2 is 28 and 3 times 2 is 6. So we get our denominator, the bottom of the fraction, the same here. And now we can just add the tops together. So we do 28 plus 19. Again, be really careful with this kind of calculation. The way I do this mentally, this is a nice little trick to know, is I generally just do 28 plus 20, which is equal to 48, and then take 1 off to give us 47. Again, a nice mental maths trick. However, we're not finished at this point. We need to convert back to a mixed number. So how many 6's go into 47? Well, we have 7, because 7 times 6 is 42, and remainder 5. So the remainder goes at the top, and then 6 at the bottom. So we get our final answer here of 7 and 5 over 6. Now, I really don't want to repeat the same thing over and over again. So we're doing subtraction, multiplication, and division in this exam sprint. Again, try and do this all in 25 minutes. It's pretty tough. So here we do the same thing. So we have 5 times 4 is 20 plus 1 is 21. So subtraction and addition work the same way. Here we do 3 times 3 is 9. Plus 2 is 11, so we get minus 11 over 3. This time we can't be so lazy. We need to change both denominators, so we can write both fractions here out of 12. So to do that here, we times top and bottom by 3. So 21 times 3 is 63. Some teachers teach this like a butterfly method, so you do this times this, this times this. This also works. Here we're going to times by 4, so 11 times 4 is equal to 44. And remember, one of the biggest mistakes made here is you forget to subtract rather than add. So we're going to do here 63 minus 44. Again, we're trying to use all those mental methods to do this. This is going to give us then 19 over 12. Again, a way of checking that is just do 44 plus 19. Do you get back to 63? Then we convert this into a mixed number. So we have how many 12s go into 19? 1, remainder 7, that goes at the top. We keep the 12 on the bottom. So we have 1 and 7 over 12. Multiplying fractions, again, we still do the same, changing the fraction to an improper fraction. So we have 7 times 6 is 42, plus 4 is 46, so 46 over 7. We're going to multiply by this one here. So 5 times 2 is 10, 10 plus 1 is 11, so we get 11 over 5. Again, we always want to see if we got some cross-cancelling here, if that is possible. Unfortunately, we don't have that here. So 7 times 5 on the bottom, that's just 35. Remember, multiplying fractions, you just multiply the top and multiply the bottom. And then we have 46 times 11. This is where the mental maths then comes in. An easy way of doing this is 46 times 10 is 460. And then we add on another 46. and that then gives me 506. So always using these quick techniques makes your life a lot easier. Now here, 506 divided by 35, okay, that's going to be a bit more tricky to work out, but we can use the bus stop method. This is the general way for dividing. So how many 35s go into 50? That's going to be 1, remainder 15, and then 35 into 156. Again, you know, roughly speaking, it's going to be times 4 here. So I get 0, carry the 2, 3 times 4 is 12, 140. So we get 4 here, but this gives us a remainder of 16. So that gives us then 14 and 16 over 35. Let's pop that in here. So 1D here, again, we multiplied fractions last time. Dividing works in a very similar way. So the first thing we need to do here is change this to an improper fraction. So we do 8 times 3, that's 24, add the 1, that is 25 over 8. And now we're going to divide by the other fraction. Again, same process. So we do 1 times 4, which is 4, plus the 3. That gives us then 7 over 4. If you find these fraction skills difficult, again, I'll put a video above, which means you can really practice those fraction skills at your own pace. Now here, when we're dividing with fractions, again, we need to remember, keep it, switch it, flip it. That's a phrase I love to use with students. So we keep the first fraction, we switch the sign in the middle to a multiply, and we flip the last fraction. So let's see what that actually looks like when we do this. So we keep the first fraction, so 25 over 8. We switch this to a times, and then we flip this fraction, which means we get 4 over 7. Now, in this case, we've actually got some cancellation that we can do, and we should always look for it. Notice we have a 4 in the top and an 8 in the bottom. So how many 4s go into 4? Well, just 1. How many 4s go into 8? That's 2. That's going to save us a ton of calculation, which is a really important thing for a non-calculator paper. So then we just do the multiplying. 25 times 1 is 25. 2 times 7 is 14. And then we convert that to a mixed number. How many 14s go into 25? That's 1. What's our remainder? What's left over? That's 11, then over 14, like so. So we pop in the answer here. Super duper. Let's move on to question 2 here. So this is a typical recurring decimal to fractions question. We want to show that 0.145 with dots over the 4 and 5 is equal to this fraction. So the first thing I like to do is actually write this out in full. So 0.1454545, carrying all the way on here. And I'm going to call that x. So I'm just going to give that a letter. And the reason I do that is I can actually work out a couple of other things here. First thing I can do here is work out what 10x is. So if I do 10x, I'm just timesing both sides by 10. Remember, that has the effect of moving everything across. So what does that mean in practice here? Well, the 1 comes here, the 4 comes here. So we get 1.454545, dot, 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 dot. Now, because we've got a recurring of 454545, not just one number, I'm actually now going to consider 1,000x. Not 100x, but 1,000x. Now the reason I do this is going to then move everything along twice. So this is going to move along twice, it's going to move along twice, this twice. So that means we get 145.4545, dot, 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 dot. Now it seems very complicated what we've been doing so far, but you're going to see what happens next. I'm going to write the 10x below. So 10x is equal to 1.4545. And I'm going to subtract one from the other. You're like, well, what kind of progress does that actually give me here? Well, 1,000x minus 10x, that's just 990x. And notice all the recurring disappears because it's in both. And all we're left with is a very simple calculation, which is 145 minus 1, which is 144. Now to get x on its own, what's the opposite of timesing by 990? We want to divide by 990 on both sides. This cancels, giving us x, which is what we're looking for, and it's 144 over 990. However, that's not the fraction we're looking for here. We're looking for this one here. If you have a quick look, we can actually simplify by dividing by 2, top and bottom. If we do that, we then get 72 over 495. So let's pop that down right here. Super duper. And now we've got a similar question. So here we've got 0.15 ... as a fraction. So again, we can approach this in the same way. 0.1515. We call that our x here. In this case, I'm actually going to work out 100x directly. So not 10x, but 100x, because I've got 2 repetitions here. That means then we're going to get 15.1515. Very similar technique. We're going to write the x down below. Again, always the target here, what we're trying to aim for is to get all the recurring to disappear, and we actually managed to achieve that. So if we minus 1 from the other, we get 99x here. Notice all the recurrings disappear. Bye-bye. I'm not going to see you again. And that gives us 15 minus 0, which is 15. And then we can divide through, just like I did in the previous question, by 99 on both sides. That then gives us x is equal to 15 over 99. And hopefully you did not fall for the trick here, which always look to simplify. And notice we can actually divide by 3 top and bottom, so we can simplify this down to 5 over 33. I hope you enjoyed that dramatic pause there. If you fell for it, then do let me know in the comments. Right, let's move on to question 3a. So we've got to evaluate our indices here. This is a really important topic, very non-calculator wise. Remember, as soon as I see a negative index, it's essentially a fraction, so it's 1 over the positive version. So what I mean there is 5 squared, not 5 to the power of minus 2. Again, important step to realize. And again, 5 squared, remember that's the same as 5 times 5, and that's equal to 25. So our answer there is 1 over 25. For this one here, again, we've got a fraction with indices. Remember, the index applies to both the numerator and the denominator. So we have 9 to the power of a half divided by 25 to the power of a half. And remember, we've got a fraction here, so some kind of root. And because we've got a 2 in the bottom, we're going to have a square root. So a square root of 9 and a square root of 25. You need to know these kind of off by heart. So the square root of 9 is 3. The square root of 25 is 5. Giving us our answer of 3/5. Now, a question I always get asked by students is, my square numbers and square roots, how high do I need to actually work these out? I would say up to 15. So 15 squared is 225. And you'd also need to know the square root of 225 is 15, and then work downwards from there. So 14 squared, 13 squared, and so on. That is important. Now, here we've got a fraction, but notice we don't have a 1 in the top, but we have a 2. That changes things slightly. What we do is separate this out. So we have 64 to the power of a third, and then we're going to apply the 2 afterwards. So we split it up in this way. Usually it's quicker doing it this way around, particularly non-calculator. Now remember, a fraction is some kind of root. We have a 3 here, so we're looking for the cube root of 64. And then we're going to do the squaring afterwards. Now, how do you work out a cube root if you don't know these? Well, think of this as something times something times something, so 3 somethings, hence the cubic root, is equal to 64. What is that something? And it has to be a whole number. It's a non-calculator paper. So with a little bit of thought, you can try 3 here. 3 times 3 is 9. 9 times 3 is 27. That's too small. But if we try 4 here, again, we can do a quick check. 4 times 4 is 16. 16 times 4 is 64. So that means then the cube root of 64, working backwards, is equal to 4. And then if we just square 4, remember this is not 8. Watch out for that. 4 times 4 is equal to 16. So we pop that in for our 2 marks. Right, on to question 4 here. Factorizing is always an important topic. Again, there's a couple of different ways that you can do this. Again, if you want more detail on factorizing, watch the algebra video above. Now here, again, factorizing, all that means is put in brackets. And because we have an x squared term, an x term, and a number, it means we're going to put into 2 brackets. So first of all, we know it has to be an x in the start, because x times x gives us the x squared. And now we've got this really important rule. I want 2 numbers that multiply to give me minus 40, but they add to give me 6. So generally how I start with this is I look at 40. What 2 numbers multiply to give me 40? Well, we have 10 and 4, we have 8 and Does 8? No, 8 doesn't work, no. But what else do we have here? 20 and 2, of course, 40 and 1. I think that's pretty much most things that we need. And the first thing that comes to mind here is I see 10 and 4. I go, okay, I can modify these to get a 6 out of it. So if I have 10 and minus 4, so plus 10 minus 4, then 10 minus 4 is 6. That's good. 10 times minus 4 is minus 40, and we're good. So we have our answer, x plus 10 and x minus 4. Again, you can always use FOIL to actually check that you do get the quadratic afterwards. Now, what's trickier is when we get a number in front. So we get a 3x squared minus 13x minus 10. Now, you can do a method. Again, I'm just going to mention this called splitting the term. But, you know, you're looking for these little maths hacks for these non-calculator exams. So I'm going to show you a quick hack here to actually do this really, really quickly. So the first thing is we have a 3x squared. So we need to have a 3x and an x. The only way we can make 3x squared. It's not like 4x squared, which you could do 4x times x or 2x times 2x. So we know there has to be a 3x and an x. And this rule still applies. So we still need two numbers that multiply to give me minus 10. So I'll just look at the 10 here generally and then just go, well, I've got 10 and 1, we've got 2 and 5, and that's about it. So thinking about it, usually with these questions, it's because the 10 and the 13 are kind of close to each other. It's kind of a rough way of doing this. I generally go or look at these two numbers first, the ones that are closer to each other, so 2 and 5, and then I need to position them in my brackets. I get this minus 13 by checking the outside and inside terms. Let me show you what I mean. So let's just try something at random. We need a minus and a plus, so let's put a minus 5 here and a plus 2 here. So I'm just going to check the outside terms. So 3x times minus 5x, that's minus 15x. Do the inside term. 2 times x is plus 2x. I get minus 13x straight away. Again, that wasn't done on purpose, honestly. So we have the correct answer. We get the middle term, and the outside term works. So we have 3x plus 2. If you want me to do the splitting the term instead, again, I'm more than happy to do that in a future video. Okay, let's have a look at the last question, so 4C. Now this is a bit trickier because we've got a 6x squared. So as I said here, we could have 6x and x and 3x and 2x. Now at iGCSE, my experience is they usually pick the closer numbers together. So this is at least the starting point that I would choose. And when you get quick at this, you can actually go through these possibilities much more quickly. Now, minus 3 is a nice number to have because it's a prime number, which means the only way to multiply is going to be 1 and 3 in some shape or form, and with 1 negative and 1 positive. So let's just pop in minus 1 and plus 3. Again, I'm just choosing this at random. And then the process I would do here, more or less in my mind, is just check the outside and inside terms. Oh god, I actually got this right straight away. I just realized. So 3x times 3 is 9x. Minus 1 times 2x is minus 2x, which is 7x. So this actually does work. But if it doesn't work, then you just try a different combination. You might want to change the signs. Plus 1 and... let's get the rubber out and just change it and just go, okay, plus 1 and minus 3. And just do a variation on this, essentially. So... this is what you kind of have to consider here. This is, again, a quick hack. Again, you can do splitting the term, the A times C method, minus 18, etc. But this is a very quick way of getting there. When you get to A level, you get to IB, it's very handy to have this kind of hack up your sleeve. It's going to make your life a lot easier. Okay, and before we go on to question 5, I just want to mention about my exclusive iGCSE Maths study group. We're going to get 10 to 15 students all working together 10 weeks before their critical exams in May 2025. If you want to be a part of this, then do sign up on the website you see in front of you. I'll put the link in the description. Right, let's continue here. So we want to find the midpoint here and the length of the line segment joining these particular points. So the way I like to do this is a quick sketch just to see what is going on here. So if we do a quick sketch of this, so it's my x and y, then we have 3, 5, it's going to be up here somewhere, and then 8, 17, which is going to be further up here. So just to get an idea of exactly what's going on, so 3, 5, And what we want to do is find the midpoint, so halfway between it and the length of that line. Now, to find the halfway point, we just need to find the halfway between the x coordinates and the y coordinates. So to work out my midpoint, I need to find the average of 3 and 8. Now, how do I work out the average here? Well, I add together the x coordinates and then divide by 2. And I do exactly the same with the y coordinates. So I do 5 plus 17 divided by 2. Now, a little bit of mental maths here. So 3 plus 8 is 11. 11 divided by 2 is 5.5. 5 plus 17 is 22. 22 divided by 2 is 11. Again, I always do a common sense check here as well. Does 5.5 and 11 make sense? Yep, it's going to be roughly halfway between these two coordinates. Now, in order to work out the length of the line, so this is a little bit more difficult. So here, imagine I draw in a right angle triangle. And essentially, I want to find the height and the length of that triangle. Now, notice the length here is between 3 and 8. So I'm looking at the x coordinate here. So the difference between 3 and 8 is 5, and the difference between 5 and 17 is 12. So essentially, we want to work out this line, and we have a length down here of 5 and a length here of 12. Essentially, we just need to use Pythagoras because remember, this is a right angled triangle. Now, I like to teach students to do this in one smooth calculation. So I just teach them here, do the square root of 5 squared plus 12 squared directly. Now we just have to do some mental maths, non-calculator of course. So we have the square root of 5 squared, that's 25. 12 squared is 144. As I said earlier in this video, you need to know your square numbers up to 15. And then we add those together, that gives us 169. And then the square root of that is equal to 13. Again, I'm able to do these quickly because I know my square numbers and I know my square root numbers. Okay, and now I do B in exactly the same way. So our midpoint, again, we can just directly use the formula. Now we understand where it comes from. So we just add together the x coordinates and divide by 2. And then we have the y coordinates and divide by 2. So let's work this out. Minus 2 plus 6 is 4. 4 divided by 2 is 2. 15 plus 9 is 24. 24 divided by 2 is 12. So our midpoint here will be equal to 212. Again, we can do a little diagram just to see exactly what's going on here. So we've got minus 2 and 9, so that's up here. And then we've got 6 and 15, so that's over here but up here as well. So working out again this line segment. The difference between minus 2 and 6, be careful here, that's going to be equal to 8. Difference between 9 and 15, that's going to be 6. So we can again use Pythagoras directly here. The square root of 8 squared plus 6 squared. So 8 squared here is 64, 6 squared is 36. Aha, this adds up to 100, and the square root of 100 is equal to 10, giving us all the marks for this question. Okay, on to question 6 here. So it's a bit of a different kind of question, definitely more towards the A star category. Give a value of A for which sine 135 is equal to negative sine of that A. Easiest way of doing this is actually using the unit circle method here. So if I just draw out, okay, we've got 0, 90, 180, 270, and then back to 360. Where would 135 be here? Well, if we go around, it's going to be roughly around here. So this would be 135 degrees. Now, because we're negative, we're working backwards. So I actually want to work out this angle here instead. Because I'm negative, I'm going down from the x-axis. Again, angles around a point add up to 360. So if I do 360 minus 135, that's going to give me then the final result of 225. Now, of course, this is a non-calculator paper, but you could check this on your calculator, put both in, and then see you get the same thing. And here we do this in exactly the same way. So we've got our unit circle, we have plus 20. We want to go around the other way, so all the way around here if this is 20, what does the other angle have to be? Well, we do 360 minus 20, and that's equal to 340. So we get 340 for our answer here. Okay, and on to question C here. So get the second value of x which satisfies these equations. So we're given here that sine x is equal to 0.7. We're told one of the answers is 44 degrees, and we want to find the other answer. Again, for iGCSE, there's a little trick you can do here, which is for sine, it's always going to be 180 minus whatever answer that we've got to work out the other answer. And that's going to give us 136 degrees. Again, the alternative way of doing this is thinking about the sine graph. So we go up and down, knowing the symmetry of the graph. We've got 0.7, which we've already worked out here, which was 44. And then we want to work out the other answer over here. And therefore, we just do 180 minus that 44. Again, the graph's a very good way of actually visualizing what's going on. Now with this one here, so we've got cos x equal to minus 0.3. Again, nice little trick here is we can just do 360 minus 107. So we can pop that in, and that gives us 253 degrees. Again, we can use a graphical method also with the cosine graph to actually show that in action as well. But again, I'm keeping this video fairly short, just going through these answers quickly. Again, it's a sprint, so we want to make sure we've got that fundamental understanding. If you're going to get the A-star grade, you need to get questions like 6 correct. Now, the last one here is classify these equations. This goes a little bit beyond syllabus because notice I've popped in circle here, but that's quite useful because if you do A-level maths paper 1, you're going to see a lot of work with equations of circles. But we can do this by elimination anyway. So if you want a linear function, then it's anything just with an x in it. So we just have an x, don't have any x squared, x cubed, or anything else. So this one here just has an x in it. So y equals 3x minus 1. So that's one that's linear. This is also linear. These are all straight lines, by the way. Gradient and y-intercept. Lovely. And we've also got this one here. So 3x minus 2y is equal to 12. So just an x term in it. If you go to quadratics here, that's anything with an x squared. You can also have stuff that's less than an x squared. So x's and numbers and things like this. So our first one here is going to be x squared minus 3x plus 1. So that's our first one. We can't have a y squared, that's going to be in our circle category. We've got y equals x squared plus 3x, that is also a quadratic, and I think that's everything here. Cubics is anything with an x cubed in, so anything with x cubed. So the first one, y equals x cubed minus 10x plus 2, that's a cubic. Y equals x cubed plus 5x squared, that's also a cubic. And I think that's everything. And then what we're left with, so anything with an x squared and a y squared in is generally a circle. So x squared plus y squared is 9 as a circle, and x squared plus y squared equals 25 is also a circle. Don't worry if you didn't get the circle parts, of course. Again, that's more for A-level, but again, those top grades as A and A-star, I want to push your understanding as quickly as possible. Again, including those questions in here in my exam sprint, I thought was a nice way of doing this. So we've gone through all of these particular questions. Again, I've put the mark scheme into the description so you can actually go through that yourself, and an empty copy of this. If you do want more exam sprints exactly like this, then I've created a set of 5 non-calculator and 5 calculator exam sprints exactly like this. Again, you can buy that by clicking the link in the description, and that will take you through, and you can get a download straight away so you can actually practice lots of these different exam sprints. Okay, hopefully you found that useful for your non-calculator preparation. Again, let me know if you like this kind of video, or you want me to do something more specific for the non-calculator skills of iGCSE. And if you're looking to improve your indices, so notice we did some indices work in question 3. Now I recommend you check out the video in front of you. And if you want to work on your trig values, so in question 6 here, then click on the other video you see in front of you.